Hello, I'm Phil Archer from the W3C. It's my privilege to be the person whose job it is to coordinate all the working groups around the area of linked open data and the broader semantic web, and even broader than that, the web of data. I'd like to thank TT Tedesco for inviting me to take part in your conference today. I'm only sorry that I'm having to do it by video rather than being there in person. Thought of a trip to Florianópolis was obviously very attractive. I'm sorry that I've not been able to make the trip. 2014 is rather a special year for us. It's 25 years since Tim Berners-Lee first proposed what became the World Wide Web. It's 20 years since W3C was formed. And such is the success of linked open data and the semantic web. Such is that success that more and more events like this are taking place, and it is so encouraging and so feel-good that LOD Brasil is here now, and I hope very much that this is just the first of a whole series of these events in the future years. What evidence do I have for this being a successful technology? What does success look like? Well, the fact that this event itself is taking place is part of that, but you can look around the world and you can see lots of different people using the technology in different ways. And some of those uses are technically quite straightforward. Linked open data itself is not technically vastly complicated. Some people will tell you it is, but it isn't, right? Something like DCAT, the Data Catalog Vocabulary. Simple vocabulary based on Dublin Core that allows data portals to publish their metadata, and more importantly, it allows other data portals to harvest that metadata and provide a place that's easy to find lots of different data from lots of different places. In Spain, that's the way they do it. Every data set that's published by the public sector in Spain has DCAT metadata that's harvested in one central place, and that's where that's how the portal operates. And a lot of data portals around the world use DCAT. The cultural heritage domain, libraries, museums, galleries, they use a lot of linked data to link together often different components of the same thing. So I saw an example where some very, very ancient biblical time documents were held in lots of different places, but using linked open data, on the screen, they all came together. The British Library, Deutsche Digital Library, lots and lots of places, Europeana, a lot of cultural heritage people using linked data. But in all those cases, the technology that's being used is relatively straightforward. If you want the technically more complicated, the ontological-based reasoning, all sorts of high-end inferencing and data analysis on often very large data sets, and you would look then at healthcare and life sciences. And there are some enormous and very important pieces being put in place across the life sciences world. Things like Open Facts, a database of 470 million triples describing pharmacological and chemical data. The Monarch Initiative, with information about in vitro models, all sorts of organisms, pathways, proteins, vast amounts of data published, as it happens, using linked data, because that's the technology that is most useful to do this stuff. In governments, particularly European governments, you'll see more and more use of linked open data. And the reason for that is actually not to provide data for third-party developers to use. It's because different government departments have always needed to share their data from this department to that department to another department or another agency or another country. And by using linked open data, that sharing becomes much, much easier. It actually makes the job of government more efficient. You can do your job of being a government better if the data is available, as much as anything, to your colleague in the next department. Never mind the separate ministry, whatever it may be. So many government data sets are needed by different parts of the same government, as well as regional and local government. So it's about that efficiency. That's what's driving the use of linked open data. And I've got various examples in the notes that accompany this short talk. A local one would be the Inter-American Development Bank Energy Information Center. That uses linked open data. That was developed by Washington, D.C. based company 3 Round Stones. Lots of use of linked data and lots of very compelling graphics drawn from that. An example of a technology that is quite simple but has had a huge impact is SCOS. Many of you will know SCOS, the Simple Knowledge Organization System. Before the web, before Semantic Web, the United Nations Food and Agricultural Organization had its agricultural vocabulary, a set of terms relevant to this wonderful industry that means that none of us are particularly hungry today. And the UN had its agricultural vocabulary, and the American government had theirs, and the Chinese government had theirs, and the French and the Germans. Everyone had their own terms. Along comes SCOS, and the FAO, Food and Agricultural Organization, published their agricultural vocabulary, AgriVoc, using SCOS. And they were able to map their terms to 16 other data sets, including all those other national versions of essentially the same thing, and to provide multilingual labels. So now, AgriVoc is a fantastic resource that has a stable URI for all those terms. It tells you what that term is in 20 different languages and how it maps to other national schemes around the world. It's a very, very powerful thing, very effective increase in efficiency based on quite a simple technology. The European Commission is publishing their authoritative lists as URIs. UK government has some shining examples of how to do this stuff. Check them out. Links are in the notes that I've provided for this. If SCOS was an early high-impact vocabulary, I think, personally, this is a personal opinion, the most recent vocabulary work that we've done, which is having a big impact, is the RDF data cube. You may be familiar with statistical data and the way that that is reported among statisticians using a hypercube model, notably the SDMX model. Well, the RDF data cube provides a way to do that in RDF. And it provides ways to provide slices through a hypercube of data. Very good for handling time series or geographic series. Actually, it turns out to be really useful for things like flight paths and weather reports from one particular place over a different time period. So the RDF data cube is having more and more traction, and I think that's a one to watch particularly. Semantic web and linked data is being used in the media, it's being used in the financial industry, it's being used in the emergency response crews. Check out Bart van Leeuwen's work, his company providing on-the-spot data to emergency crews as they go and fight fires or tackle accidents or whatever it may be. You may not like it, but a lot of the Secret Service stuff that goes on, that Edward Snowden brought to everyone's attention, a lot of that uses linked data. We're working on geospatial data, we're working on e-commerce, more web payments and so on. And if you want an example of the fundamentals of linked data, the underlying principles of the semantic web and linked data being used on a massive scale, really, really successfully, often without people realizing that's what they're doing, take a look at the success of schema.org. Schema.org, what is that? It's semantic markup within pages that helps you tell the search engines what your page is about. And it is massively successful. Last time I heard, 6% of all internet domain names and 21% of all web pages included some form of schema.org markup, helping the search engines to classify content, organize it, and provide better search results. That's a massive success. And these things are based on mature technologies. Earlier on this year, W3C published the updated versions of RDF 1.1, so we now finally have standards for turtle and trig and triples and quads. Sparkle Update is all done. There's an awful lot of work went in, so those technologies, they've been through the mill, they've been used, tried, tested in all sorts of different areas, and now they are fully stable, and we're ready to move on. If you want to point at one particular technology that's had a huge effect within that set of standards, take a look at JSON-LD. JSON-LD is a fantastic way. It's such a beautiful way that links the linked data semantic web world with the web developers who are never going to use Sparkle, who are never going to write a Sparkle query and don't think in graphs. So are we finished? Have we finished the semantic web? No, we haven't. It's never going to be finished. W3C will continue to support the development, the deepening, the enrichment, the gap filling where we see gaps. We'll do that, we'll carry on doing it. We're working on tabular data, we're working on general best practices, we're working on RDF validation, we are very soon working on geospatial information, all sorts of gaps that need filling in to make sure that the web of data really can be successful and used across the board. But it would be silly of me and you to think that we're home and dry, to think that the whole world is looking at us and saying, yes, that's what I want. No, they're not. We have a lot of people who don't like us at all. We have a lot of people who think we're a bunch of time wasters. We have people who think that the semantic web is a bunch of solutions looking for a problem. It's overcomplicated, over-engineered. You've heard those. So how can we tackle that? Well, we tackle it first of all by presenting all the evidence that it's not true. And when I say URI, I actually mean URI. I might mean IRI, but I definitely do not mean URL. People, there are some people who get upset by that. I make no apology for talking about URIs and not URLs. I make no apology for being proud of what the semantic web and linked open data does. There's an awful lot there, but we do have to make ourselves more friendly and more available to other people. JSON LD is a huge step forward in that, because you can process it as JSON, or you can process it as JSON LD. You can use the LD part to process it as RDF, that's fine. But we also need to provide better interfaces. We need to, I think, go further than JSON LD does. We need to look at, yes, of course, using persistent identifiers on the web to get stuff, and point out that when you dereference a URI, what you get back is the same data, whether it's in JSON or XML or one of the RDF serializations. It's actually technology neutral. But we still have to go further than that. There's work going on in community groups like the Hydra community group that we have, which is defining a standard way of describing APIs, such that one bit of software can tackle multiple APIs. There's work going on, again, this is not W3C work, but work on making it better to do federated queries by taking chunks of data from lots of places and running the one query locally. The idea there is to enable developers to write smart clients based on smarter servers. There's all sorts of things we have to do, and we do have to reach out to regular web developers in much the same way we reach out to regular commercial customers. You don't go to a commercial customer and say, I've got this Sparkle 1.1 update engine here, and it does some really cool RDF inferencing, and it's got some OWL ontological processing as well. So you don't do that to a client. You say, with this technology, I can solve this problem that you've got. Here's a server that can do something really clever. It helps you solve your problem. That's what we have to do to talk to the regular web developers and make our technology more available to them in a format that they like, that doesn't require them to understand Sparkle, that doesn't require them to think in graphs. If we can do that, if we can make our technology more available and more easily accessible to regular web developers as well as commercial clients, we keep building the breadth of industries where linked open data is being used, and we keep deepening the technology stack so that it can do reasoning where needed and do simple things with high impact where that's enough. If we can do all that, then maybe in 2015 we can get together again and celebrate yet another year of success for the semantic web.